Let's take a look at this problem. We've got 2 sine theta minus 1 is equal to cosecant theta. And we want to solve the equation on an interval of 0 to 2 pi. Well, first off, I'd like to get them the same trig function if I can. So I can rewrite the cosecant as 1 over sine. Well, we've just created fractions. We want to get rid of the fractions, so we multiply everything by sine. So sine times 2 sine minus sine times 1 equals sine times 1 over sine. When we do that, these sines are going to cancel. And then we'll have 2 sine times sine is sine squared minus sine. Now I'll bring that 1 over to the left side and becomes a negative 1. Now if you want to see if it'll factor, then what you can do is you can replace your trig function with a variable like p and do it over on the side. So we'd have 2p squared minus p minus 1. I don't need equals because I'm just trying to factor it. So that'll be 2p, p, 1, 1. And that'll be a minus and then a plus. Let me double check that. Okay. That's how that factors. But we don't have p over here. So we're actually put the sign back in. So this becomes 2 sine theta plus 1. And this will be sine theta minus 1. Now the zero factor property says if you get 0 on one side and you factor the other side, you set each factor equal to 0. So I'll set 2 sine theta plus 1 equal to 0. And I'll set sine theta minus 1 equal to 0. Now this one, I'll take the 1 over, becomes a negative 1. Divide both sides by 2, and we get sine is equal to negative 1/2. Sine is equal to negative 1/2. This is, what was that, 6 pi over 6. So this is 7 pi over 6. And this will be 11 pi over 6. This point here is negative square root of 3 over 2 and negative 1/2. And this point over here is positive square root of 3 over 2 and negative 1/2. Now we're looking where sine is equal to a negative 1/2, which is right here and right here. So our two answers from this part is 7 pi over 6 and 11 pi over 6. Now let's look at this other piece. I'll take the negative 1, move it over, becomes positive 1. Now this point right here at pi over 2 is the point 0, 1. And we're asking when is sine equal to 1. Sine is a y part, and it's equal to 1 right there. So this would tell us that theta is equal to pi over 2. Okay, maybe. So 7 pi over 6 and 11 pi over 6. And pi over 2. We need to plug those back into the original problem and make sure that they check. You can change things out of different trig functions, but it's always a good idea to check to make sure it doesn't cause anything to be undefined, what you come up with. 7 pi over 6. Sine of 7 pi over 6 is negative 1/2. 2 times negative 1/2 is negative 1. Minus 1 is negative 2. And if I put 7 pi over 6 in over here, then cosecant of 7 pi over 6 would be 1 over y. And so that'd be 1 over negative 1/2, which is negative 2. So that checks. Okay. 11 pi over 6. If I put 11 pi over 6 in here, sine is still the same y value, so it checks too. And if I put the pi over 2 in, sine of pi over 2, sine is our y, so we'd have 2 times 1, which is 2, minus 1, which would give us 1 here. And if I put cosecant pi over 2, cosecant is 1 over y, So I had 1 over 1, which is 1, so I get 1 is equal to 1. So all three of those actually check. And those would be your answers.